Hello, hello. Okay, we are doing the cube root function today. Just like the square root, think about what you can take the cube root of. Well, yeah, okay, so we can take the cube root of 0, and that is 0. You can take the cube root of 1. Good. What else? 8. Okay. What about the negatives? Can I take the cube root of -1? Heck yes, you can. And then -8, -2. So those are our 5 parent function points. They are, in case you noticed, switched from the cube function, which makes sense because they are inverse functions. And what do we know about inverse functions? Their x and y values switch. Ha-ha! So now you're getting to see it in action. Pretty fancy. Okay, so as we graph, we're going to see that it is curvy. It is reflected across y equals x from its inverse function. Okay, every parent function's hk is 0, 0 because there aren't any horizontal or vertical translations. The x-intercept is 0, 0. I don't need my keypad. The y-intercept is 0, 0. The domain, all real numbers. And the range also is all real numbers, which is the same as its inverse. Even though by definition they switch, they are all real numbers. This one is increasing. What that means is as x goes from -infinity to +infinity, our y values are getting bigger. Okay, it's not decreasing. It is 1 to 1 because for every x, there is one and only one corresponding y value. And then for every y, there is one and only one corresponding x value. The rate of change varies. You'll learn how to do that later in pre-calc honors. There isn't an axis of symmetry. We don't have maximum and minimum values because the domain and ranges go off to infinity. And there aren't asymptotes. So we'll finish that off. Sweet. So there is our parent function. Hello. All right, so let's transform it as is always. As is always. Yep, okay. We're gonna rewrite it with the b transformation here too, so we have it to refer back to. A is on the outside because it affects our y values, as does k, and then b and h affect the x. All right. Looking at our second example, technically our first, we can see that a is 2, okay, which means that we are gonna have a vertical reflection because our y values are increasing by 2 units. Vertical reflection. There isn't a b other than 1. Our h is -2, so we go 2 units left. And then the k is 6, so we go 6 units up. Excellent. All right, so b affects x, but it's 1, so we're going to have x -2 because -2 is our h. A affects the y, so we have 2y plus 6 because 6 is you guys can on your paper. Okay, so if we plug in -8, we get -10. If we plug in -1, -3, 0, -2, 1, -1, and then 8, 6. For the y's, if we plug in -2, we get -4 plus 6, which is 2. If we plug in -1, we get -2 plus 6, which is 4. And then 6, and so forth. Finish it out with me, please. And then we'll graph. So -10, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6. Oh gosh. Graph it the right way though, please. 7, 8. And then 1, 2, 3, 4, 5, 6, 10. All right, so definite stretch we can see with those coordinates. All right, let's fill in the characteristics. We know that hk is going to be from our transformations written out, -2, 6. There is going to be an x-intercept because it will eventually, and I don't like that this is straight, sorry guys. It will eventually intersect the x-axis. Your graph should be curved. There we go. So we'll find it algebraically. Yay, I know you're excited. So I'm going to plug 0 in for y, and that equals 2 times the cube root of x plus 2 plus 6. Let's do it. I'm going to subtract 6 to both sides, and we get 2 times the cube root of x plus 6 on the right. Divide both sides by 2, so we get the cube root of x plus 2 is equal to negative 3. Cube both sides, do the inverse operation to get rid of that cube root. So x plus 2 is equal to negative 27, and x is negative 29. Yeah, we're not graphing that. That sounds awful. It's really far away. Okay, so we'll write it as a coordinate negative 29 comma 0. Yay! And the y-intercept, oh man, I see it, but I can't approximate. So we need to find it algebraically. I'm going to take 0 and plug it in for x. So we have 2 times the cube root of 0 plus 2 plus 6. And I don't, without a calculator, know what the cube root of 2 is. Nope, I can approximate, but I don't need to. I just need to be able to find it. So I'm going to write it as 6 plus 2 times the cube root of 2, because that is more proper notation with the radical at the back. All right, nice job, guys. Domain and range, all real numbers. We saw that last time, or negative infinity to positive infinity. You know how much you guys like writing the infinity symbol? Okay, this one's also increasing because we don't have any sort of reflection. Yes, it's 1-to-1. Our rate of change varies, and we don't have an axis of symmetry. We don't have minimum or maximum values because our domain and range goes off to infinity and negative infinity, and we don't have any asymptotes. So you're stoked because that bottom half of the chart is an A. And there's example number 1 or 2, depending on how you look at it. All right, let's go to our last example. The one that, of course, is going to have that B value because we need the practice. Switching colors, what do we do? What do I do? I factor out the B value. Now remember when you factor, you're dividing. So I'm going to take a positive 1 and divide it by a negative 3. And what do I get? I should get negative 1/3. Okay, 1 divided by negative 3. So that's all you're doing when you're factoring out. A is 1, so there isn't any vertical change. B is a negative 3, so there's 2 transformations here. The first one's going to be a horizontal reflection. And then we're going to have a horizontal compression. Why? Because it's 3 in the equation, which means we're using the reciprocal of 1/3 in the chart. Okay, H. H is 1/3, so that means we're going 1/3 units right. And K is 0, so we're not going up or down at all. Let's go ahead and write our chart. Our chart's going to be a negative 1/3, like we mentioned, times x plus 1/3, and then y is going to stay the same. And just like I did, I'm going to write out the parent function points. Negative 8, cube rooted is negative 2. Negative 1, cube rooted is negative 1. 0, 0, 1, 1, and then 8, 2. Okay, if we plug in negative 8 for x, we get 8/3. 8/3 plus 1/3 is 9/3 or 3. So 3, negative 2. If we plug in negative 1, we get 1/3 plus 1/3, which is 2/3. And negative 1. 0 gives us 1/3 and 0. 1 gives us 0 and 1. 8 gives us negative 8/3 plus 1/3 gives us negative 7/3, or negative 2 and 1/3. Okay, whatever is easiest for you when you're graphing. So let's graph it. So 3, negative 2, and then 2/3 negative 1. Obviously, when we're approximating, it's going to be a little bit difficult, but just do your best, you guys. So 2/3 negative 1. 1, oh, fudge. Okay, 2/3. Come on. There we go. 1/3, 0, and then 0, 1. And negative 1/3 and 2. 1, 2. Oh, no, no, no. a little bit touchy at times. Okay, and I don't know why this is so large. That's why. Okay, so let's go ahead and connect our points as curvy as possible. And we can see that there's definitely a compression, not as stretched out as our normal parent function. Okay, so let's fill in our chart, guys. HK, we wrote it down. HK is going to be 1/3, 0. The x-intercept, you luckies, is in the chart. It's 1/3, 0. The y-intercept is also in the chart. No algebra for us in that respect. We know that the domain and range is all real numbers. If we look, we can see that there is a reflection, so we're decreasing. There's only one reflection, so they don't cancel each other out per se. Instead of our y values increasing from left to right, they decrease. It is 1-to-1. The rate of change varies. And there isn't an axis of symmetry. It's not symmetrical. We don't have minimum or maximum values, and we don't have horizontal asymptotes. So there it is. All right, nice job, guys. So our cube root parent function.